Good afternoon, everyone. I'm NIHARIKA Sharma. I'm going to present a study on review on structural solution for irregular shape building, a way forward. So moving ahead with the introduction part, uh, considering the development of any country, that is dependent on the overall infrastructure development. So as we can see, following the traditional system that has been progressively abandoned in the favor of more efficient structure, that is allowing us to do more design challenges. Means we need to adopt new design or structural systems for future of infrastructure development. A few of the examples that can be seen here is CCTV headquarters, China, then Maizil, which is a shopping center in Germany, then Sukhov Tower, which is in Russia. It is basically a diagrid element that has been awarded Best Tall Building by CTBUH, that is Council on Tall Building and Urban Habitat. So few of the examples are there in in the overall environment, and we can see that yes, new design concept has to be introduced. So maximum cases we can see that diagrid has been adopted as a structural system. So, as per my study, my main basic study is Voronoi, that is irregular type of grid. So, this particular study that has been adopted in nature, as we can see that the surface of leaf, then on the surface of giraffe, irregular type of grid that has been seen. So, based upon these observation, it has been observed that these type of irregular grids can be used as a structural element in tall buildings, which can be made or which can be prepared by using Voronoi tessellation of different irregularities that can be made through irregularities of honeycomb structure or naturally providing an irregular shape of Voronoi structure. So on the right hand side, we can see that irregular type of grid that has been adopted, which will be and which can be adopted and taken as a overall structural load on this particular type of grid. A few of the literature survey that has been adopted for this study are moving ahead with the first part, that is innovative concept on structural engineering of mega tall building. That is the year of publication is 2017. I'll be taking a few of the key papers that has been adopted. In this particular study, a mega tall building has been taken into consideration, and overall design and analysis has been done in ETABS, and the major part of the structural system that has been adopted was outriggers. So overall comparative study that has been made in this particular study, and one conclusion was made that the drift and displacement, storage drift and displacement were better in case of diagrid as compared to outriggers. So based upon a few of the literature survey, the research gap has been made. Number one is that diagram has applied to special optimization task in urban and architectural work, and structural implementation still needs to be studied. So this particular literature survey says that overall irregular study has been made only till architectural phenomenon and not till the structural. So this particular grid can be adopted for structural element, and we can use this particular study to see what impact it will make in comparison to diagram. As in maximum tall buildings and in maximum skyscrapers, only diagrid level has been adopted till now, and moving ahead with the diagrid, hexagrid has been adopted. So hence, Voronoi grid can be the future of tall buildings. That is the overall research gap that has been made. Then what is the need of this particular study? As we can see that due to scarcity of land, it is important to adopt vertical construction more than compared to the horizontal part. Then a reduction in the overall self-weight of the structure is to be required, which can be obtained by using complex geometries only. And as if we are moving again with the traditional structural system, we will not be able to cope up with the design challenges that will help us to increase the overall height of structures. Then steel prove to be the lightweight material, and hence tall buildings we are adopting steel. Then what is the main objective of the study? Major objective of this particular study is to understand the scope of this particular irregular geometry over a conventional part, and to propose a structural system of Voronoi tessellation. Voronoi tessellation is basically this irregular grid that can be seen in an AutoCAD diagram, where irregular type of grid has been adopted, and overall structural system can be used, and peripheral columns can be provided, and overall lateral loads can be distributed in better manner as compared to a different structural system. And this particular design analysis can be done by using finite element method, and on tall building, taking steel as a structural building, and the software that can be taken is SAP 2000. So this is how, what exactly we can do. On the left hand side, we can see that a diagram has been given, and on the right hand side, that diagram is very uniform grid, but this Voronoi grid is an irregular grid, and we can use this particular grid for design and analysis. These are few of the models that has been prepared in Stanford. It was just an attempt. And the methodology that can be adopted here is considering a 50-story steel building. Then overall floor height that can be taken as 4 meters. Then IS code, IS 800 and IS 875 can be considered. So all these parameters that can be adopted, that we are considering for conventional type of structures. So the conclusion that can be made, as this is just a review paper, the conclusion that can be made is that application of grids in tall building is the future of infrastructure, and extension or diagrid extension is a Voronoi grid, as it will reduce the displacement with increasing height of the steel building. Then irregular grid gives comparatively less displacement as compared to less story drift, and specifically for lateral loads acting on building. These are few of the references that has been adopted. Thank you.
Thank you for your presentation.